Let's compare values from different data sets. So we can't compare apples to oranges. You've probably heard this a million times in your life. So if we take apples and we turn them into pears, and then we take oranges and we turn them into pears, now we can compare them because they're the same fruit, right? Same thing happens with numbers. We can standardize the data. We can turn everything into z-scores, and then we can compare. Because z-scores are based off of the mean and the standard deviation of that particular data set. So we work within a data set to find a z-score, and then we can compare z-scores because they're all the same. Well, they're all pairs, right? So remember the z-score formula. Z-score is the data value minus the mean over the standard deviation. Z equals X minus mu over sigma. I like to always think about it in terms of words. I find that a whole lot easier to remember than just symbols. So let's jump into an example. A student in math scored an 81 on a test with an average of 75 with standard deviation of 2.6. Their best friend scored an 86 on a biology test with an average of 87 with a standard deviation of 2.1. Who scored better relative to their test, and why do you think that? Okay, so let's just look at, first let's look at math. But we're comparing it to biology. So this is where you can say, well, this is apples to oranges. We're talking completely different subjects, completely different test type, all of these different things. So how can we really compare? So instead of comparing math to biology, we're going to turn math into a z-score, and we're going to turn biology into a z-score. And then we can compare the z-scores. Whoever has the higher z-score did better on their test. Okay, so let's look at math. Math, you scored an 81 with an average of 75, so mu is 75, and a standard deviation of 2.6. So the z-score, X minus mu over sigma, gives me 81 minus 75 over 2.6. So that's 5 over 2.6. Oh, typo. Sorry. 81 minus 75 is 6 over 2.6. Glad I caught that. Which gives me a z-score of 2.31 rounded to the nearest hundredth. Great. There's math. Awesome sauce. Let's go to biology. Your best friend scored an 86. Well, good for your best friend. Average of 87, so mu is 87. Standard deviation of 2.1. Some of you might already be like, well, I know the answer to this one just by looking at that. And yeah, you might have it. So X minus mu, so 86 minus 87 over 2.1. Well, 86 minus 87 is negative 1. And negative 1 divided by 2.1 gives me a negative 0.48 rounded to the nearest hundredths. So you can see the math student scored 2.31 standard deviations above the mean. Well above average, right? High five to the math student. Whereas the biology student might have scored an 86, but that's actually below average, right? Because the average student got an 87, your friend got an 86. 86 is by no means a bad score. It's just below average. So when you're comparing who did better on their test, it was the math student, which makes sense because math is phenomenal.